Hi, this is Sandhya. I'm doing major project in Valtech University. Uh, Here I'm taking the title of analysis of crop yielding using machine learning techniques, and I'm taking the guidelines of supervisor. My supervisor name is a Ganeshan sir, and this is my industry details. Present I'm doing internship in this industry. For taking in this project only, I'm taking this industry only, and this is a total agenda today, and this is the abstract. In this abstract I mentioned as here I am taking the sector of agriculture. In agriculture sector, now agriculture is a main backbone of Indian subcontinent. It deals with the growth of Indian economic, and is a 70% of citizen rural areas, and 10% of citizen urban areas, and 5% of citizen for cities contribute their effect of farming and providing yields in own respective fields. So for some other fields, so here I am taking the crop in agriculture sector. I am taking this crop yield while season wise crop data I collected, and I am showing like which season which crop will be using high and crop yielding is more high. So I am taking this one. My total result is here. I am taking the uh, result in this using the linear algorithm and random forest. I'm showing proposed approach of 80% existing method in these times of accuracy and efficiency and predict the crop yielding with random forest performing the best overall. And I'm coming to my aim of the project here to develop a software package model with might useful to scan the info for data set wherever the large quantity of knowledge are going to keep and may be simply recoverable exploitation and some machine learning models with assistance of Google Collaboratory, and to develop a machine learning model with assistance of linear regression model wherever the info will be retrieved and saved within the sheets that area unit, helpful for additional prediction in linear regression model that runs in the Google Colab, can retrieve from the sheets may create it simpler to scan any data. Here I am using to develop the code in the Google Collaboratory, and there I showing this graphical modes and using the training and testing the model. And coming to my scope of the project, the main scope of the project is develop a code or model with the assistance of rectical linear regression which can produce a prediction having high accuracy even with few attributes within the data. Here all the data collecting from the government website, and this is where response for this project will come under on the real time, because in agriculture we have take all the data from government website and showing the based on climate changes and based on the soil resistance, we can using the algorithm as random forest regression and linear algorithm to representing the overall the data. And here coming to the introduction, in India agriculture is the main backbone of society which provides a huge amount of crops which are used for various purpose like eating, commercial, and some are used for providing oils for cooking purpose. The rapid increase in population of India's virtual climate variation, food supplies and demand change required to maintain the high amount of production. So in this project I run the code from random forest regression using the SQL and also on graphic. I am showing this graphical representation mode to the overall the crops data and crop name, production cost, and some internal measurements like potassium, sulfur, and nitrogen, humidity, and water resources, which are playing a major role in the growth of the crops. And these are the literature reviews. I'm taking the references of these literature reviews, and I'm taking this information and all in the some of government official websites and collect all the information in this website only, and overall the data and which needs high quantity of knowledge to store. And in every literature paper I'm taking the reference of the journals, and these are the design and methodologies. In model 1 collected data with the linear regression, model 2 is retrieving the data and information using the linear regression, model 3 is analysis the data with QAD analysis, and model 4 is predicting the model with high accuracy using the quadratic discriminant analysis. And collected this is the model 1. Here I'm showing the all collecting the data using of temperature, humidity, and potassium rainfalls and label. And here the retrieving the data, here I'm using the coding part of in Google Collaboratory to execute all code, and all it's showing as a graphical representation. See here I'm showing the graphical representation to agriculture production, and this is the what are the temperatures are having in this data I'm showing in the graphical mode only. And these are the standards and policies, and this is the overall architecture diagram, and this is the data flow diagram. It is showing a stepwise data: crop yielding, linear regression, applying random forest, obtaining x and y training data. Here x and y is a training the data and testing the data, so it is showing the data flow diagram. And this is the ER diagram, and this is from sequencer diagram. And this is the testing. Here testing is done for every model in the project. So models are data importing the data, processing data, execution with the help of the linear regression and QAD analysis. And this is the white box testing. Here I am using this model to different training and testing the models, and to showing to outputs of coming the functionalities, and importing the data and SQL and model are used. And coding also I mentioned. Here the screenshots are available what are got I am in this. This is a X training data, means it is a training data, and Y training data set, and these are the outputs using the confusion matrix. And finally it is concluding, it showing like models like linear regression and random forest regression helpful in generating the training and test the data set, which are helpful in predicting purpose, and training and testing models are enhanced for achieving higher accuracy in the production. And I am developing to the coding part also, I will show after this slide. And this is the future enhancement will predict and will available as application where everybody it is very useful to this checking the farmers and all. It is very less cost, and they will know how which season and which crop we can use. And without non-agriculture non-educational piece also we can see by using the graphical representation mode. And these are the web references I am taking, and these are the references for taking the generals. And coming to the coding part, I will show you. Here I'm coming to the coding part. Here I will execute this one, and here we can upload this one Excel sheet. I'm showing that is a temperature, humidity, and that's one this Excel sheet. So it is successful. And here also we can run it showing the data. I will show the data what showing. See here the sample data is showing. One is this is nitrogen, potassium, and sulfur, and temperature, humidity, and potassium, rainfalls, and label. And this is the matrix, and it's showing this is the confusion matrix. What are the data it's showing? Like it is temperature, humidity, rainfalls data. And this is the graphical representation: nitrogen, phosphorus, and potassium. And this is that all the graphical representation, how much temperature and humidity and rainfalls and potassium is showing. And this is the crop wise data is showing apple, banana, black grams, and all. It's showing like arrays and all. And this is the coding part, and this is using for this Google Collaboratory. And here it's showing the data. This is the decision tree. In decision tree, training data is 99% we can did, and testing data is 100%. And KNN and random forest also, here I'm telling no random forest regression. So here I'm random forest regressions, I'm trying both the training and testing the models. And see here the using the apple, banana, black gram, and all crops. And it's showing into the it's like as a confusion matrix, and it confusion matrix for the training model in the random forest. So it's showing this true label. prediction. This is the confusion matrix for training model, and I did also confusion matrix with testing model, and this is the testing the model confusion matrix. And this is the quadratic analysis, and this is the quadratic discriminant analysis part. And here also I am using this data, so this data will produce here. This is the nitrogen, phosphorus and potassium. This is the temperature for this data, and this is the humidity how, and this is the rainfall percentage, and this is the potassium percentage, and this is the decision making tree, the code. And here I am showing the testing and training the models, same data it will come. And this is the X, X training the model. And why is it testing the model? So it's showing this output like this, and this is the overall the data for this crop wise. So here while using this temperature, humidity and rainfalls, using how much nitrogens are there, how much phosphorus are there, based on this one only we can find out this crop data. And the soil is this much quantity as available, means in this season we can have this crops. It will showing as based on climate changes, so that is called humidity. And we can soil as we can check as a nitrogen data. So here we can take this data from this some government websites, and we can show as a, here I in first I submitted one shoes file, no, that is all taking from this government website only. Based on that only I did this coding from this is I wrote in this Google Collaboratory. So this is my project. Thank you.